Hello, this is Jack Gassett with Gadget Factory again, and this is part 2 of the overview of the SUMP Logic Analyzer VHDL code. And we left off talking about the UCF or constraint file, and I'm just going to start over with that. And basically, the constraint file allows you to define which pins are going to connect where on the actual physical Xilinx chip. So in your top level module, which is the Logic Sniffer module, you always have to define your ports, and we have ports such as the actual input pins. So we have 32 input pins, and our triggering clocks, our main clock that connects to the oscillator, our SPI pins, our UART pins, and our LEDs. And we need some way to define to the Xilinx chip, or actually just define how those ports get connected to the Xilinx chip, and that's done in the constraint file. And to modify the constraint file, you select it and you do edit constraints text, and it will bring it up. And this is where, so we basically define that the 50 megahertz oscillator is connected to pin 41, and it has a period of 20 nanoseconds. And so you can modify any of these and switch these around. Okay, so let's move on and take a closer look at the top level module and see what there is to learn about that. So at the top, we define our ports, and then from there we define all of the different components that we're going to use. It's kind of like a header file in C. Then we define our variables, our constants, and this is where our actual architecture begins, the actual code where we instantiate our components and other things that we do. We also define our processes here. And it's important to keep in mind with VHDL that everything happens in parallel. So if we define a process or we instantiate a component, they all act in parallel. So the first important thing, and you can actually kind of look at the comments and pick all this up, but basically the first process handles choosing the inside or outside numbering scheme, and it also connects the waveform that generates the test mode to the inputs. And it's pretty straightforward if you take a look at it. Alright, so moving down, the next area of interest is this is where we implement the clock. So these are DCMs, and what they do is, in the case for the Logic Sniffer project, we have a 50 megahertz oscillator, and we implement a DCM that doubles the clock to 100 megahertz, and that's what allows us to sample up to 100 megahertz, and to sample above that at 200 megahertz. Michael Poppets has implemented a double data rate sampling scheme, so it will sample on both the rising and the falling edge of the 100 megahertz clock. And moving on, next we have the section that controls whether we're going to implement the SPI module or the UART module, and all this does is instantiate the modules and make the connections to the ports on the top level. Finally, we have the core. This instantiates the core and makes all the connections. And we have our implementations of the different memory depth options that we have. And this is wrapping up part 2.